Okay, good morning, children. Uh, Today we will be discussing about mechanism of electrophilic substitution reaction. Mechanism of electrophilic substitution reaction of benzene. We know that benzene has a pi electron cloud above and below, and since it is a pi electron cloud, it is rich in electron. Benzene is rich in electron. Uh, that is the reason why an electrophile which is poor in electron can easily attack here, and we will get the product. We will get the product, this one, and with the loss of a electrophile. So one electrophile is attacking and forming this with the removal of another nucleophile. With the loss of another electrophile. That's electrophilic substitution reaction. Benzene undergoes electrophilic substitution reaction. There are different types of electrophilic substitution reaction that we are doing now. First, we'll be doing is your halogenation. So halogenation is can be represented like this. Suppose plus Cl2. It happens in presence of catalyst AlCl3, and we get the product plus HCl. So this is one example of electrophilic substitution reaction, and we will now discuss about its mechanism. How is this happening? Okay. So now you see this this AlCl3, which is acting as a catalyst. You can write like this: Al and chlorine molecule. So this is chlorine molecule, this is AlCl3. Now one thing in AlCl3, you see aluminum has surrounding it six electrons. 1, 2, 3, 4, 5, 6. Aluminum has 6 set of electrons, so it will have a tendency to have another pair of electrons to make it octet. Because of this tendency, this chlorine molecule will undergo heterolytic fission. It will undergo heterolytic fission, and this Cl with the pair of electrons will get attached here. Cl with the pair of electrons will get attached here. So what will result because of this? It will be Cl, and this Cl with the bond with the electron pair will get attached to it. So Al, Cl, 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 Cl. So this one will be formed. Now this Cl has lost its share of electron. So this Cl will become Cl plus, and if you calculate formal charge in aluminum has now 4 electron in the outermost shell. Normally aluminum has 3 minus. So this is the first step. So here Cl plus is formed. Normally we don't come across Cl plus. Here Cl plus is formed, and the name of this Cl plus, it is chloronium ion. Chloronium ion, and it is the electrophile. Cl plus is the electrophile. Okay, now in the next step, suppose this is step 1. In the next step, what happens is we take up now benzene. Benzene has a double bond in alternate position, and then this Cl plus chloronium ion, which is an electrophile, will attack. So it will attack, say here, and Cl plus, since it is poor in electron, so this pi electron will break and it will come here and it will help in the attack of Cl plus. So Cl has got bonded, and there is already a hydrogen bonded to it. That we can show it here now. Yes, and since electron has gone from this carbon to this side, this carbon will become positively charged. So this is an intermediate, and this intermediate is called a sigma complex. Sigma complex, like we have discussed about carbocation intermediate, we have discussed about carbanion intermediate, free radical intermediate, and this is another intermediate which is called sigma complex. Okay, the next step is, so let me write step 3. So here this this Cl, this bond comes back here. Oh, sorry, not this one. Not this one. This bond for H, it comes here. It comes here, and this H comes out as H plus. This H comes out as H plus because this bond is coming here, and this H plus then reacts with this species here, and it forms your plus AlCl3 plus HCl. So you see, we got the product, and AlCl3 is regenerated. AlCl3 is regenerated, and we can say that this AlCl3 is acting as a catalyst. So this is how mechanism of this is what the mechanism of halogenation is. So one very important thing to remember here is that in halogenation, this is the electrophile that is generated, Cl plus. So in this way, there are some other electrophilic substitution reaction that I am doing now. Next, suppose I am doing nitration. So let me write the equation for nitration. Benzene plus nitric acid in presence of sulfuric acid. Actually, we use here concentrated nitric acid and concentrated sulfuric acid, and we get the product plus water. So this is nitration, benzene plus nitric acid in presence of sulfuric acid. We get nitrobenzene. This compound is nitrobenzene plus water. So how this happens, the mechanism. Let us discuss the mechanism of this reaction. Here we have to find out which is the electrophile. If in the previous case Cl plus chlorinium ion was the electrophile, so what is the electrophile here? So here it is like this, H2 as a 4. Now first ionizes as H plus and 8SO4 minus. Then this HNO3 whose structure is like this. This is HNO3. Now this double bond, this oxygen is 2 pair of electron, 2 lone pair. So this proton comes and it gets joined here with this lone pair. So this proton has got joined with the help of this lone pair, and now you can calculate the bond charge surrounding oxygen. There are now you see how many? 1, 2, 3, 4, 5 electrons. One less. So this O becomes plus. O plus is called oxonium ion. In the next step here, what happens is since we know oxygen is highly electronegative, and now this is O plus. O plus will be more electronegative, and this bond electron will immediately go towards oxygen, and we get this water unit. So water will be formed. So like this is a byproduct water, and this NO2 unit, which has lost its share of electron, so it will become NO2 plus. NO2 plus. So this is the electrophile here, and the name of this electrophile is nitronium ion. So nitronium ion is the electrophile in nitration. Okay, so suppose this is step 1, this is step 2. Now in step 3, what happens? Just see, you see this benzene. This benzene will be attacked now by this electrophile, NO2 plus. NO2 plus. So when this one attacks here, in the same way this pi electron will help in the formation of bond by coming here. So what will become is this like this. And since this carbon has lost its share of electron, so this carbon will become plus. So sigma complex is formed, and in next step, what will happen is, as before, this H will come, this bond will come here, shift here. There will be loss of proton. There will be loss of proton. So that suppose I am writing it here only in the next step. So we will get NO2. So this is the product we were supposed to get. So we got that, and here, as already said, there will be a loss of proton. So this is next. Then one more step you can write is this H plus that is formed. It recombines with HSO4 minus, HSO4 minus, to get back H2SO4. So you see, this H2SO4 is acting as a catalyst because it is regenerated, and this reaction, is called nitration. In nitration, the reagent that we use, it is a mixture of concentrated nitric acid and sulfuric acid. This mixture of concentrated nitric acid and sulfuric acid, it is called a nitrating mixture. So in this way, there are some more reactions, the mechanism you have to practice. Okay, I will ask you to practice the mechanism for other reactions. What are the other reactions that will come? You will see in your book, it's written sulfonation. Sulfonation. You have to practice yourself sulfonation. Then another type of reaction that will be there is Friedel-Crafts reaction. Friedel-Crafts reaction. And Friedel-Crafts reaction will be of two types. Friedel-Crafts reaction. One is called Friedel-Crafts alkylation. Friedel-Crafts alkylation. Another that you will get is Friedel-Crafts acylation. So children, you should understand this mechanism. You have to practice this mechanism by writing, and after that you should try to take on this mechanism. You have to find out for yourself by consulting your NCERT textbook. You have to do the mechanism of sulfonation. You have to do the mechanism of Friedel-Crafts reaction, which is of two types, alkylation and acylation. These are very important because time and again, in almost all chapters in organic chemistry, this electrophilic substitution of benzene, will be coming. So children, this much for now. You have to practice it a lot. Organic mechanism is all about practice. The more you practice, more you'll come near to perfection. This much for now. Have a good day. Bye bye.